Hi everyone, welcome back to my channel. Let's continue from where we left off in the previous session. Today we will be moving ahead with the next part of the topic, so let's get started.
Okay, now let's do the question number 5. A hemispherical depression is cut out from one face of the cubical wooden block such that the diameter of the hemisphere is equal to the edge of the cube, and we have to determine the area of the remaining solid. Now, if you're observing the figure, in the question itself they have given us two hints. The first hint is that the hemispherical depression is cut out from one face of the cubical wooden block. A cube have how many faces? It have 6 faces, but here this groove is cut down from where? From a single face, and the shape of the groove is what? It is a hemispherical shape. Okay, and the diameter of the hemisphere is equal to the edge of the cube. So here if you are observing, this is the circular base of the hemisphere, right? And they tells us that if you the diameter, if I'm drawing the diameter like this, or let this diameter, if I'm drawing it in this way, it touches where? It touches the edges of the cube, right? They are touching on the edges of this cube, right? So from the second figure it is very clear that this region is actually to show you that the entire figure is like a hemisphere. Like we have grooved a hemisphere inside a wooden block. So inside the wooden block there is a hemispherical groove. Okay, so this is what, from here till here, this is the diameter. Okay, from here till here it is a diameter. Okay, and this is the height of the what? Height of the hemisphere. This height of the hemisphere will be equal to what? This hemisphere's height should be equal to the radius, right? Radius. Why? Hemisphere is what? It is a half of a sphere. And in order to draw a sphere, actually we are having it will be half hemispheres. This depth will be equal to what? Equal to the radius of the hemisphere. So now they have given us the diameter of the hemisphere is equal to edge of the cube, that we have to write. Diameter of hemisphere is equal to what? Edge of cube, which is equal to, it is given in the question like how much? It is given as L, right? It is equal to L. Then what they have given? They have given, therefore if diameter is equal to L, then what will be this radius from here till here? Then, or from here till here, what will be the radius? Radius equal to L by 2, right? So we will write, therefore radius equal to, therefore R equal to L by 2, right? Then we have to find, they are asking us to find the remaining area when we, like this much area, what is this leftover area? That is what they are asking us to find, right? So first we will have to find the total area of the cube. Then we will have to find what? From there we will have to reduce the area of hemisphere, right? Then we will get the remaining portion. So first, in order to do that, let me do all those things in a single step. That is, total surface area of solid, that will be equal to what? It will be equal to surface area of cube. From the cube, what you will have to do? From there, you will have to add the CSA of the hemispherical part, right? Plus CSA of hemisphere. Then from there, what we will have to do? From there, we will have to reduce the area of the base of the hemispherical part, right? Minus area of base of hemispherical part. Clear? That in this way we will have to do that one. That is, first we have to do what? We have to find the entire area of the cube, surface area of the cube. From there, what we will have to do? We have to add the CSA of the hemisphere. Okay. Then what we will have to do? Then from there you will have to reduce this base area of the hemisphere, right? Area of the base of the hemisphere. Then we will get the TSA of the remaining solid. Okay. So first let me write, that is TSA of remaining solid equal to surface area of a cube. What's the surface area of a cube? Cube surface area equal to 6 into L square, right? Here 6 into L square plus surface area of a CSA of a hemisphere. What's the equation for the CSA of a hemisphere? It is 2 pi r square. From there, what you have to do, you will have to reduce the area of the base of the hemisphere. That means the circular region you will have to reduce. What's the area of a circle? It is equal to pi r square, right? From there, you will have to reduce pi r square. Okay, now look here. You can see that when we are reducing this pi r square, what will happen? That is equal to 6L square plus 2 pi r square minus pi r square is equal to pi r square. Clear? Now, this is the leftover equation. So, now what we can do here is, so our value equal to how much? 6L square plus pi r square. Now, one more thing from the equation, you can note it down. This L equal to how much? Total L equal to the, if you are observing from here till here, the diameter is equal to the edge, means that length is equal to diameter, right? Here we have written, right? So, L equal to what? L equal to D, which equal to 2R. Clear? D equal to how much? 2 times R. From there, I can write an equation for L. What is L? L equal to 2R, or I can rewrite R equal to how much? R equal to, L equal to 2R. So, either I can convert this L to R or R to L. Here, what I'm going to do is that I'm going to find an value for R. R will be equal to what? If I'm taking 2 to the opposite side, it will become L by 2. So, I got my value for R equal to L by 2. So, let me substitute that value here in this equation. 6L square plus pi into R is equal to L by 2 the whole square. Okay, that is 6L square plus pi L square by 4. Here we will have to take the LCM. Here, on taking in the LCM means, here also 1 means I need to multiply both the sides with 4, right? Here also 4, here also 4, because my LCM is 4. So, I will be getting 6 4s are 24. 24 L square plus pi L square by the whole divided by 4. Now, I can take L square commonly outside, which is equal to L square into 24 plus pi the whole divided by 4. This can be also written as L square by 4 into 24 plus pi square unit. This is the answer. Okay. Now, let's do the question number 6. A medicine capsule in the shape of a cylinder with 2 hemispheres stuck to each of its end. The length of the entire capsule is 14 mm and diameter of the capsule is 5 mm. Find its surface area. Okay, so now look, they are telling that this capsule, entire capsule's length is how much? Length is 14 mm and diameter of the capsule, it is given as how much? Diameter is 5 mm. That means from here till here, when we are calculating the circular region, this one diameter, it's equal to how much? It is equal to 5 millimeter. And we have to find the surface area. Okay. If that is the diameter means, what will be our radius from here till here when we are calculating from here till here? This is the diameter, right? Diameter is equal to 5 mm. So, radius means how much? Half of diameter. That equal to radius will be equal to 2.5 mm. Now, let's do the calculation now. Given the diameter of the, so let us write, given diameter D equal to how much? D equal to 5 mm. And therefore, radius will be equal to what? Radius will be equal to 5 by 2, which is equal to how much? I can write it like the 2.5 mm, right? I got my radius like from here till here. The radius R equal to how much? R is equal to 2.5 5 mm. Clear? Now we have to find the length. They have given us length of the capsule. Length of capsule equal to how much? Length equal to total length is 14 mm. Okay, now if you're observing here, this length is actually, this figure is actually a combination of how many figures are there in total here. You can see from here till here and here till here. This is actually what, from here till here it's a cylinder, right? And this one is a hemisphere, and similarly this is also another hemisphere, right? So this is a combination of two hemispheres and one cylinder, right? Now we have to find, we have to find the area of each items. Like each figures we will have to find the area, because they are asking us to find its total surface area. So first we will have to find the area of the hemisphere, single hemisphere. Then we will have to find the area of the cylinder. Then we again have to find the area of the hemisphere. Then add them all together. Then we will get the entire area of the surface area of this cylinder, right? So for that one, first let me write length of the capsule we wrote. Now we will have to find, because first we have to find the area of the cylinder, right? Therefore, in order to find the cylinder's value, I need first what? I need the length of the cylinder. Length of cylinder. What's the length of the cylinder? If I want to find the length of the cylinder, from here till here, we know that it is the radius, right? And here till here, that value will be equal to the radius of the hemisphere. That means this value, how much we got for the radius, which is equal to 2.5. Here also we got the value as 2.5. This 2.5 and this 2.5, we need to reduce it from the 14 millimeter, which is the total length of the capsule. Therefore, length of the cylinder will be equal to, it's equal to 14 mm minus what? 2.5 plus 2.5, which is equal to 14 mm minus 5, which is equal to how much? 9 mm. Now we got the length here till here, the total length we got it as like how much? 9 mm, right? Now we need to find the surface area of the hemisphere. Okay, why we are taking we only need the CSA of the hemisphere. We don't want that LS, means total surface area. We need the CSA of the hemisphere. Okay, now, but let us find the surface area of the hemisphere, which is equal to, let me write, surface area of hemisphere equal to, what's the equation for the surface area of a hemisphere? It is equal to 2 pi r square, right? Which is equal to 2 into pi equal to 22 by 7 into r. We got r as how much? R is equal to, I can write it either like the 5 by 2 or you can write 2.5. Anyway, you can use it there. Then r square, right? So I need to repeat it 2 times. That means, what's the value for this one? It is equal to 275 by 7 millimeter square. This is the surface area of one hemisphere. Okay, how many hemispheres are there in total? There are 2 hemispheres are there in total. Now we need to find, therefore, area of 2 hemisphere. It is equal to how much? It is equal to 2 into 275 by 7, right? So this value we can find it at the end, no issues. Now we need to find the surface area of the cylinder, because we found only what? Surface area of the hemisphere. We need to find, we found it like what? Single surface area for the hemisphere. We only found the length of the cylinder. Now we need to find the surface area of the cylinder, right? Surface area of cylinder we need to find out. What's the equation for finding the surface area of a cylinder? It equal to 2 pi RH, 2 pi RH, which is equal to 2 into 22 by 7 into R equal to 2.5 into, what's the H here? H is equal to 9 millimeter square, right? We found here, right? Here we found the length of the cylinder. Length is equal to the height. In the case of the cylinder, length is equal to the height. Therefore, our height of the cylinder is how much? 9 mm. That we need to substitute here into 9 mm square. That is equal to how much we will get here? The value is 22 by 7 into 9. Okay, so we will get here into 45. Okay, into 45 mm square, which is equal to 990 by 7 mm square. This is what? This is the surface area of a cylinder, right? And surface area of the cylinder is 990 by 7 mm square. Now we need to find the total surface area of the capsule, right? Therefore, surface area of capsule equal to how much? We need to find the, we have to add the total area of hemispheres, means there are two hemispheres, therefore we need to add which value? This value. Then we need to add what? Surface area of the hemisphere, this value we need to add all together. Then we will get the total value, which is equal to 2 into surface area of one hemisphere plus what? Plus surface area of cylinder. Okay, which is equal to 2 into 275 divided by 7 plus 990 divided by 7. This much we need to add. That is equal to what? 2 into 275 means 550 by 7 mm square plus 990 by 7 mm square, right? So how much we will get? Which is equal to 1540 by 7 mm square. Then okay, so which is equal to 1540 divided by 7 will gives us 220 mm square. Okay, this is the value for what? The surface area of the capsule. Therefore, the surface area of the capsule equal to what? Hence, surface area of capsule is 220 mm square. Clear? Now let's do the question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of canvas of the tent at the rate of 500 per meter square. And here one more thing you have to note down, that the base of the tent will not be covered with canvas. Like as shown in the figure 1, the first figure, you can see that there is no canvas covered in the base, right? In that way you will have to take the figure. Okay, so here what all things are given? First they have given the shape. Base is a cylindrical part. Above the cylinder a cone is kept, and thus we have made a tent here. They are telling the height and the diameter of the cylindrical part are 2.1. Therefore height is how much? 2.1 meter. So height of the cylinder is equal to how much? 2.1 meter. And the diameter of the cylindrical part, they are telling what? The diameter of the cylindrical part is how much? It is 4 meter. Therefore this value equal to what? 4 meter. And the slant height of the top, they are telling slant height means from this height, right? This is called L, which is called the slant height. Slant height of the top, it is given as how many meter? 2.8 meter, right? And what they are asking us to do here, we have to find the area of the canvas. How much area we need to buy for making such a tent? That is what we have to find. And we have to find what's the cost of the, if the cost of the canvas per meter square is 500, therefore for the entire canvas which we are purchasing for making this tent, how many rupees we will have to spend on it? That is the question. So first what we have to do, first we have to find the total area of this tent, right? Then only we can purchase the canvas. First let us find the total area of this tent. For that, what we have to do first we have to find the area of this CSA of the cylindrical part. We are not finding the TSA. Why we are not finding TSA? If we are finding the TSA means we will have to include the circular part which is coming in this region as well as the circular part which is coming in this region. These two values we don't want to add because what it's a tent, right? Therefore, here this region is also hollow, and this region we are not taking that region because that region is we are not covering the base part. So no need to find the area of the base circle as well as the area. So we just need to find the CSA of the cylinder. Okay, no need to find the TSA here. So first what we have to find? We have to find CSA of cylinder. Okay. So in order to find the CSA of a cylinder, what all things we need to find here? 2 pi r h, right? This is the value for finding this is the equation for finding the CSA of a cylinder. Now what all things we need to do? Again we need to find the CSA of the cone, right? There also there is no need for finding what base area of the cone. We need to find only the CSA. What is the CSA of a cone? It is equal to pi r l. Clear? Now, what we have to do after finding these two values, we will have to add them. Then we will get the entire area for this tent. That means the total surface area is what? Total surface area of the tent equal to area of the tent. It is equal to how much? It is equal to the sum of these two values. That is, we have to first add the CSA of cylinder. To that, what we have to do? We have to add the CSA of cone. Then we will get the total area of this tent, right? What is the CSA of a cylinder? CSA of a cylinder equal to 2 pi r h plus pi r l, which is the CSA of a cone. From here, what we can do? We can take pi and r as the common values here and we can take it out. So pi r, so what is left over? 2h plus l is left over in this equation. Now let us substitute the values. Pi equal to how much? 22 by 7 into r. R equal to, if the diameter is 4, then the r of the cylinder will be equal to what? We are finding it for the cylinder, right? Therefore the cylinder's r equal to radius of the cylinder equal to 2 meter, which is equal to 2 into what is the height of the cylinder here? Here the height of the cylinder is 2.1 meter, which is equal to 2.1 plus L. What is the L given? L is the slant height. Slant height is given as 2.8 meter, right? Plus 2.8 meter. So now what we will get here? That is 22 by 7 into 2 into 2.1 plus 2.8, which is equal to 44 by 7 into 2 this is how much? 2 into 2.1 is 4.2 plus 2.8, which is equal to 44 by 7 into 4.2 plus 2.8 is equal to how much? 7, right? Now what we can do? This 7 and this 7 get cancelled. So we will get the value 44. This much meter square is there. Therefore, the total surface area of the tent is how much? Surface area of the tent equal to surface area of tent equal to how much? Equal to 44 meter square. That means 44 meter square what? Canvas is required for what? For building. That much canvas we need to purchase not to build the tent. Okay. And they are telling one more thing. For 1 meter square, what's the value? For 1 meter square, we have to pay rupees 500, right? Therefore, for the 44 meter square, means for the 44 meter square, we will have to pay how much? 44 into 500, right? That much value will be there for a total canvas. Okay, if you want to buy the 44 meters square, that much length canvas, means we have to pay how much? Rupees, like 44 into 500. Now let's do that in a step. We have to, therefore, cost of the canvas of the tent at the rate of what? At the rate of rupees 500 per meter square, right? Per meter square, right? Therefore, which is equal to how much? Surface area into cost per meter square, which is equal to, what's the surface area here? Total surface area is equal to 44 into cost per meter square is 500. So that will give the value what? 22,000. That means rupees 22,000 is required for buying the canvas. So rupees 22,000 will be what? The total cost of canvas. Clear? Okay, let's do the question number 9. A wooden article was made by scooping out a hemisphere from each of a solid cylinder as shown in the figure. If the height of the cylinder is 10 centimeter, they are telling what the height is equal to 10 centimeter, and base radius means from the center from here till here, the radius equal to what? It is equal to 3.5 centimeter. Find the total surface area of the article. So once after removing this hemispherical part, we have removed that region out from the solid figure. Okay, from the solid cylinder we are removing here. Since I just showed it in the transparent method, in order to make you clear that you can see the copper colored one hemispheres, right? 2 hemispheres. Those regions are the grooves inside it. Okay, actually those regions are hollow region, and the rest transparent region is a solid figure. Okay, so now look, so what we have to find? We have to find the solid part. That means from the entire cylinder, we have to reduce what value? We have to reduce the area of these 2 hemispheres. Then we will get the remaining surface area of the article. So first what we have to find? We have to first find the, here, what all things are given? Height of the cylinder is given, then radius of the cylinder is given. So from there what we have to do? We have to find the CSA of cylinder. What is CSA of a cylinder? What's the equation for the CSA of a cylinder? It is equal to 2 pi RH. 2 into 22 by 7 into, what is the R given? 3.5 into H is given as how much? 10, right? So how to find this one? This 3.5, in the yesterday's class also I explained that the 3.5 can be written as how much? 7 by 2. So now look, this 2 and this 2 we can cancel, this 7 and this 7 we can cancel. So we will get which value? We will get 220 centimeter square, right? Now we have to find what? We have to find the area of hemisphere, right? That is the cavity, that is the groove inside that one. That area first we have to find. Therefore, inner surface area of hemispherical cavity. Here there is no need for finding this circular area, means base area. Why? Because we are making a groove inside that, right? That groove means this is the region that which is creating inside that figure, right? So it means what? We have to just find the CSA of the hemisphere. Okay, which is the inner surface area of the hemisphere. It will be equal to, which is equal to the CSA of hemisphere, which is equal to what? Which is equal to 2 pi r square, which is equal to 2 into 22 by 7 into r equal to again 3.5, which can be written as 7 divided by 2. This also, then again one more 7 by 2, because it is r square here. This 2 and this 2 will get cancelled. This 7 and this 7 will get cancelled. And this 2 and this 22 will get cancelled, and we will get how much? 11. So the value equal to 77 centimeter square. We got the value of 77 centimeter square. What we have to find? We have to, how many such areas are there? How many such grooves are there? 2 grooves are there. Therefore, total area of hemispherical cavity. How many such cavities are there? 2. That is 2 into 77, which is equal to how much? 154 centimeter square. Okay, now what we have to do? We have to find the TSA of the solid. TSA of the solid, it is equal to what? CSA of, which is equal to CSA of cylinder plus what? Plus total surface area of the hemispherical cavity, right? Or otherwise you can write like the inner surface area of both hemispherical cavity. Clear? Which is equal to, what is CSA of the cylinder? CSA of the cylinder is equal to 220 centimeters square plus total area of the hemispherical cavity is equal to 154 centimeter square. So in total what we will get? 374 centimeter square. This is the total surface area of the article. Okay. Thank you for watching. If you found this helpful, please subscribe and stay connected.